Welcome back. Oh, I got snot all over my face. It is so cold out here. Welcome back to part 3 of building a real Ragebringer. In this part, we're going to work on socketing the crossguard. Now, normally you would do that with a drill and a file, but we have this milling machine here, and I've only used it one time. So the majority of this episode is going to be preparing the stock and the machine to mill that socket. Let's get to it. When we finished up last week, we had polished off the center line that goes down the blade. And that center line wasn't exactly centered anyways. So we're going to start off this week by reestablishing that center line. The first step is to apply fresh layout fluid to the tang of the knife, and only the tang. We just spent time polishing the ricasso. We don't want to have to do that again. It'll be difficult to get a straight edge to balance on the blade now because it's no longer flat. So what we do instead is to spin the straight edge between two pieces of steel that are the same thickness as the blade. That'll give us a nice stable surface so we can get a nice clean line scribed. Here you can see how the tang will socket into the crossguard. So we need to cut a rectangular hole through our crossguard. And for our crossguard, I have a piece of bronze stock that is just the right size. Another option would be to cast it in bronze, but in this case we're just going to grind it out. So we roughly mark the shape of the crossguard, and then we can move on to cutting this piece off to a more manageable size. To cut it, we're going to use a regular jigsaw. A band saw would be better, but I don't have one. So we just mount it in the vise, and we use a jigsaw with a standard metal cutting blade on it. The only special thing we need to do is to keep the cut lubricated, and for that we're just using standard old WD-40. We will be using the digital readout function of the mill to make sure we're cutting in the right location, but it's still a good idea to put some layout lines anyways. Here we're doing a no-no. We're using our calipers to scribe lines, and then we use our machinist square to put a center line on the face. This center line will line up with the center line we previously scribed on the dagger. Then we use a center punch to dimple where those two lines cross. That'll be the very center of the socket. And then we use some dividers to measure half the width of the blade from that center line we scribed. Then we can use that divider like a compass in that dimple that we set. And we can strike an arc on the left and the right side of the dimple, and that'll correspond to the left and the right edge of our socket. And here you can see that the width of those markings matches the width of the tang. To make sure that the crossguard fits snug, we want the end mill that we use to be slightly smaller than the tang of the knife. So here we're measuring the tang at 0.188 inches, and that means we're going to use a 3/16 end mill, which comes out to 0.1875 inches. If you're unfamiliar with it, an end mill can be drilled into a part, but you can also move it side to side to make lateral cuts with it. On the top right here, we have the socket and the dimensions, and this corresponds to this part on the tang. On the left here is the end mill measurements. We want to plunge the end mill into the center of the metal to cut that socket and then move it to the right. However, if we move half the width of the tang, that'll put our end mill outside of the edge of that socket by half of its width. So we don't want to move left and right by half the width of the tang. We want to move left and right by half of the width of the tang minus half of the width of the end mill. And that'll put us right at the end. And then we can use files to square up those corners. An end mill gets plunged into the part and then moved left and right to cut out the material, but it can't do that at full depth. It would bog down and bind up. So you do it in sort of a zigzag pattern, stepping down slightly, but you don't go full width or full depth. Once you get close, the very last cut you do, you go all the way to the left, all the way down to the bottom, all the way to the right, and all the way back out. That will give you a clean, single pass cut that doesn't jam your machine up. Now we plunge the bit into the part and we start slowly cutting that material out. We are getting quite a bit of tool chatter here, but ultimately this is going to be on the inside of a part and we're going to be cleaning it up with hand files, so I'm not super worried about it. I do have the chip guard removed so that I can film, but if you see my head peek in from the left side, I'm wearing a full face shield as well as a full grain leather apron. Intermittently, you want to come in with a brush and kind of clean some of those chips up, as well as coming in every once in a while with a general purpose oil and keeping that cutting surface nice and lubed up. Our full cutting width on the y-axis is going to be 0.864. That's the number we calculated earlier. We center the mill when we start, so that'll be negative 0.432 in one direction and positive 0.432 in the other direction. As I mentioned when we were planning out the cut, we're not going to cut to that full width until the very last pass. So if you watch that y-axis readout, you'll see we're only going to negative 0.4 inches and positive 0.4 inches. All right, we're starting to sneak up on that final depth. And in the case of this cut, the final depth is just as deep as we can take it. That's what she said. We're doing our final cleanup pass now. So we're going to take the y-axis indicator all the way to that 0.432 inches, and then we're good. From there, we just back the mill out and then clean our part up. The edges of your cuts will also get a small metal burr, and you want to clean those up with a regular hand file. Now, when we inspect this, you might notice a little bit of a problem. Our socket doesn't go all the way through the part, but when we grind this, we're going to remove a semicircle of material from the other side, and that'll remove the portion that doesn't have a socket. I haven't mentioned the pommel or the peen block yet, but they were done in pretty much the same exact way. The only difference is for the pommel, we had to mill in from both sides so we could get a hole all the way through. And that can be a little problematic, but it's also pretty boring to watch. Well, that'll pretty much do it for this week. Hit that subscribe button and the notification bell because next week we're going to actually start working on shaping the crossguard and the pommel. See you then. Bye.